are their perceptions of what they need for the next couple of years for their market developments, what are traffic trends, we see also what other airlines do. So that is the feedback there. So we are handling all these airlines within the group and some of the other units, like we work closely with Lufthansa Flight Training, Lufthansa Technik, and a couple of others. So there's the evaluation, the strategy, the purchasing and disposition, all that is centralized, but each airline or each unit is responsible for their capacity requirements, because we centrally will not tell them, you Swiss will grow 6%, you Passage will grow 7%, you Austrian will grow 8% or whatever. They need to have the market for it. And we could just challenge them and say, is your planning too conservative? Because don't think about next year, what you want for next year, because there's the Olympic Games or there's the soccer championship in Brazil or whatever. But think a little bit longer term. So it's an iterative process. We get involved with the manufacturers extremely early, because like people usually focus on this part of the equation, which is production and then the purchase. But once the aircraft is being produced, you can't change much. You can improve, you can tweak a little bit here and there. Like we can put a vortex generator on a vent in order to reduce the decibel of noise. But we can't change a significant amount of things. The big things you can change, and it's like with your car. You want to reduce your fuel burn on your car, which you have purchased already, the only way is lift your right foot. That's the only way. You can't really do much more. And similar here. So what we try to get integrated into the OEMs is when they commit the cost of operations, that we actually give them the feedback. If you do this, this has this repercussion on the operational cost. And hence, by the way, just as a side effect, that means you have to discount your aircraft by X in order to be competitive. So there is a very strong motivator for the manufacturers to listen and to take some of those elements in. And I like using this one. I know there's a couple of aircraft on there which are not real aircraft, but some of them I took real pictures, some of them are just worked upon. But I think the element is, what we have to understand is we're a safety-driven industry, so we are extremely conservative. And the black text here basically is a summary of a memo which was written in the 50s why the DC-8 technology would not work. And we all know the DC-8 technology did work. And the same questions were put to a forum of engineers about what would you see as positives or as stopping points for the blended wing aircraft. And the same thing came up. Why it doesn't work. So we're extremely conservative, and we sometimes need to kick ourselves to look a little bit ahead on the horizon. We still need to keep that safety consciousness, but sometimes we're just too conservative. That's really all I want to say in here. When we want to understand the aircraft, we obviously have the privilege of having Lufthansa Technik. And that is a big privilege because we get a lot of technical work done on the aircraft and the engines. And hence, we understand how they perform in service. We understand what it means to modify a cabin conversions. Because we all know that if you want to convert an aircraft from one airline to another airline, or when you want to convert an aircraft because after 7 years or whatever it takes, our product is outdated and we want to change it, what does that imply? Do we have all the flexibility? Can I actually design, if you think back about the 80% cost incurred, can we actually put some sufficient flexibility into the airframe that the cabin conversion is done like at a short notice, that we don't need a 2-year lead time or something. So this is what we're learning, this is what we integrate into our products, and this is, for example, At a certain point, because the market was, Lufthansa wasn't at the size of today, the market was extremely volatile, and we had, and still have, a quick change aircraft. Quick change for us does not mean freight at night and passengers during the day, or vice versa. Quick change for us means we can vary the size of the business class. And Lufthansa is unique in being able to do that. There's no other airline who has that flexibility built into their basic specification of the aircraft. So we can increase or shrink the size of the business class at literally 1 day's notice. We can only do it in Frankfurt because you need some extra seats or to take some seats out. So we can't do it in New York or something. That would be too complex. But we can do that with very short notice to react to the market. And this is something which we learned from actually having the work of Lufthansa Technik. That flows into my department, that flows into the specification requirements we put to the airframers. And there we are. So when we look at the current and emerging trends, and yes, we have gone a certain way, but we like our heritage as well, and maybe just as a small side slip, the Superstar, or Super Constellation, well, we are rebuilding Superstar at the moment. We have bought a couple of them, and we're building one nice one out of them, which will be certified to today's standard, fully compliant for scheduled passenger transportation. Don't worry, LH 400 or something from Frankfurt to New York will not suddenly move back to that one, because I think 20 flight hours or whatever it took are no longer state of the art, but it's part of our technical heritage that we understand the aircraft very well. Now, the big question on the market, and this is the eternal discussion which we always have, when everybody looks at the market and says, oh, is it the right aircraft, or is it the wrong aircraft, or I need better seat markers, yeah, but I can't fill it. You all know these arguments. And like, if you have a unit cost curve over the size, over aircraft size, you have traditionally something like that. Then the question is, what happens if technology moves that somewhere further down? Is actually the right aircraft for that market because you're just targeting a seat mark cost, or do you actually have a market which does require, say, the 150-seater? Or do you just need something which has the cost position of the 150-seater, but tomorrow you may have that cost position on a 100-seater? So what is the right aircraft? How do we see the market development? That is one of the crucial discussions we have within the Lufthansa Group when we look at new aircraft and the sizing of the fleet. The sizing, not the number of aircraft, but the sizing of the individual aircrafts. So that is part of our modeling as well. Then I said about flexibility, and no, there's nothing missing here, because I just said low-cost models in '96, Europe looked like that. If I would draw the whole number of lines which we have across Europe today, it probably looks like the box on the right. So there's nothing missing. It is looking like that today. So that meant we needed to adapt our fleet. That meant we need to look forward. If business models change, can we actually adapt our fleet? Do we have the right production tools for it? And the answer is yes. We just modified the interior of our A319s, because a lot of these guys use either 737s or 319s. And we have already, with some of the flexibility we build into our specification, we have been able to increase the seating without needing a floor strengthening or whatever you may think about. So that's like the forward thinking, which sometimes puts a little bit more effort into the specification. Sometimes may put $1 more into the purchase price. But when you look over the life cycle of the aircraft, we save a ton of money. The other thing we need to look at, because we're a scheduled carrier, we have low-cost competition, we are a network carrier, and let's just pick a Frankfurt-Hong Kong run. We have, on a specific day, we have like 50 origins feeding into that long-haul flight. And they come from as far, and they are ranked by the number of passengers, so most of the passengers came out of Hamburg. But you even have people coming as far from Buenos Aires to connect to that flight. So we need a functioning system of planning, capacity management, and most importantly, a lot of reliability. So a lot what we're focusing on when we look at aircraft is how do we manage the reliability? Because this is like a well-greased system. Every single unit has to work. If one thing doesn't work, it puts a disruption in. So we need to focus a lot on all the reliability elements. And is just one example, and by the way, still about 10% of all the passengers on that flight would go beyond Hong Kong. So, how do we evaluate aircraft? Like here, there's a little bit of a collection on the left-hand side. It's not the Lufthansa fleet, it's a collection of aircraft which we could choose from, or which we can choose from, which doesn't necessarily mean we'll choose all of them. And the scene is set really in the single-aisle market. You have the E2s, you have the 737 MAXes, you have the C919. I haven't updated it. You could update that probably on a 6-monthly basis in terms of the entry into service dates. I left it with the original entry into service dates. Some of them have moved, you know that. But these are really the aircraft which are available on the market for individual segments. So that's what we would be evaluating, and put also a risk assessment against how probable are the entry probabilities of certain promises of certain manufacturers. When we evaluate aircraft, and this is something like, it's a list, it's not a complete list, but I think it covers the most important points. And obviously, when we want to get an aircraft, it has to satisfy certain criteria to match the market. And the market is cabin size, but it's also all the performance elements. And it is a cost element. So that's, everybody understands that. If you don't have the range to go to Buenos Aires, but you want to go to Buenos Aires, it's not very advantageous. Yes, you can do a stop, but if you only have water, it becomes very unhealthy. And so, what sort of technology is there? What sort of materials is there? What does it apply for our maintenance organization? What does it apply for ground times? Is the new technology actually lengthening overhaul intervals? Therefore, do we actually get more flying hours over the life of the aircraft? Therefore, is it more efficient? Can we actually save one aircraft because we need less spares? So these things, all of these things go in. We look at the maintenance schedule. We look at the engine technology. Is it a promising technology? Before we actually bought the C-Series, we evaluated for 2 years the engine on the C-Series because we looked at the engine as the crucial part in the design. And before we actually said we were willing to evaluate that aircraft, we evaluated the engine technology. And that's what I mean with technology. We know we always get new avionics, new requirements, and new possibilities. And to give you one example, the flight management computer on a traditional aircraft is probably something which in computing power equals a 286 processor. Nobody today works on a 286 processor, even if you have a BlackBerry or an iPhone. So they are like light years ahead of that 286 processor. But some of the aircraft basically have that. And you cannot go to Best Buy or anybody else to buy a little bit of extra memory and put it into the memory bank if you need some more airport databases or things like that. So how do we work with that? And how do we keep an old architecture for our fleet? And we try to convince other airlines to go with us, that we have a long life for that asset. At least that it doesn't become obsolete because we can only fly to one continent and then the memory bank for navigation is done. And then we only, at the base in Frankfurt, we have to reload the memory bank now next week it's Asia, so get the Asian data and take the North American data out. So this is not very efficient way of use. Hence, we focus a lot on avionics and interfaces. I think on the environment, I don't have to say a lot. We all know that noise, CO2 and pollution is key to us. And one thing I'd like to say though is noise is usually, it's partly it's normal noise, like there's the engine running. Partly it's aerodynamic noise. Aerodynamic noise, which is a large fraction of the current noise development, is basically resistance, it's drag. Drag means I burn more fuel. So actually I don't need any incentive to work on noise. Because my incentive is I have roughly $9 to $10 billion fuel bill per year for this. If I can shave 1% off that, that's a visible number. So I don't need anybody to tell me, oh, you're too loud or so. We know when we see something, what we want to work on to improve the product actually even in service. And we do a lot of modifications which we put onto the aircraft and which we push into the manufacturers, even though sometimes it takes a couple of years before they actually adopt them. But like 90% adoption rate for